Ladies and gentlemen, welcome.
Where you live the language.
Classroom C2 for business.
Classroom C2 for life and culture.
Classroom C2 for education.
Hello. Hi. Good morning. Good afternoon. Good evening.
Classroom C2 at the cutting edge of technology.
Classroom C2
Where you live the language.
Okay, good afternoon, everybody. Here we are again with this new program in Radio Nia JC, Classroom C2. Okay, apparently today I am alone with this program, but anyway, today we want to bring a subject that is very popular these days, as it is the vaccination, right? Trying to get a better understanding how a vaccine works, what were its origins, and how people during this couple of centuries have been improving how a vaccine works. So basically, is trying to tell people that the vaccine is really necessary. So in order to come back to our new normality, if we can call it that way, and that they don't fear taking a vaccine, because we are contributing to going back again to the normality, and try to our economy goes flourish again, and we can start again with our duties. So first of all, I am going to show you a short video about the origins of the vaccine, how the vaccine was originated, and how it has been improving during the years, and it has been with the help of the technology being day by day a little more reliable for our health. So I am going to share this video in order that we can understand a little better how a vaccine works. Okay, screen. Right here.
10,000 years ago, a deadly virus arose in northeastern Africa. The virus spread through the air, attacking the skin cells, bone marrow, spleen, and lymph nodes of its victims. The unlucky infected developed fevers, vomiting, and rashes. 30% of infected people died during the second week of infection. Survivors bore scars and scabs for the rest of their lives. Smallpox had arrived. In 1350 BC, the first smallpox epidemics hit during the Egypt-Hittite War. Egyptian prisoners spread smallpox to the Hittites, which killed their king and devastated his civilization. Insidiously, smallpox made its way around the world via Egypt. In May 1796, Jenner found a young dairymaid, Sarah Nelms, who had fresh cowpox lesions on her hand and arm, caught from the udders of a cow named Blossom. Using matter from her pustules, he inoculated James Phipps, the 8-year-old son of his gardener. After a few days of fever and discomfort, the boy seemed to recover. 2 months later, Jenner inoculated the boy again, this time with matter from a fresh smallpox lesion. No disease developed, and Jenner concluded that protection was complete. His plan had worked. Jenner later used the cowpox virus in several other people and challenged them repeatedly with smallpox, proving that they were immune to the disease. With this procedure, Jenner invented the smallpox vaccination. Unlike variolation, which used actual smallpox virus to try to protect people, vaccination used the far less dangerous cowpox virus. The medical establishment, cautious then as now, deliberated at length over his findings before accepting them. But eventually, vaccination was gradually accepted, and variolation became prohibited in England in 1840. After large vaccination campaigns throughout the 19th and 20th centuries, the World Health Organization certified smallpox's eradication in 1979. Jenner is forever remembered as the father of immunology. But let's not forget the Buddhist nun, dairymaid Sarah Nelms, and James Phipps, all heroes in this great adventure of vaccination, who helped eradicate smallpox.
Okay, as we could see in this video, they were mentioned the smallpox disease, that which was a pandemic in what about 3-4 centuries ago, and they were trying to combat this disease at the time, and they invented many ways in order to improve a vaccine for this disease. In this case, at this moment, they didn't have the technology that they were developing over the years. But anyway, they tried to fight with this new disease at that time. Anyway, as you could see in the video, they always try to invent new ways to combat this disease. What we need to understand is that vaccines are, in a basic way, is a way to activate the immune system to protect it against an infectious disease. So the activation occurs through priming the immune system with an immunogen, that is an antigen, which stimulates the immune response with an infectious agent that is known as immunization. Vaccination includes various ways of administering immunogens. We need to know that most vaccines are administered before a patient has contracted a disease to help increase future protection. However, some vaccines are administered after the patient already has contracted a disease. Vaccines given after exposure to any particular infection are reported to offer some protection from the disease or may reduce the severity of the disease. Remember that the first rabies immunization was given by the famous Louis Pasteur to a child after he was bitten by a rabid dog. Since its discovery, the rabies vaccine has been proved effective in preventing rabies in humans when administered several times over 14 days, along with rabies immune globulin and wound care. Other examples include experimental AIDS cancer and Alzheimer's disease vaccines. Such immunizations aim to trigger an immune response more rapidly and with less harm than natural infection. We need to understand that most vaccines are given by injection as they are not absorbed reliably through the intestines. Like attenuated polio, rotavirus, some typhoid, and some cholera vaccines are given orally to produce immunity in the bowel. while vaccination provides a lasting effect. It usually takes several weeks to develop. This differs from passive immunity, which is the transfer of antibodies, such as in breastfeeding, which has immediate effect. When a vaccine fails, it's not because of the vaccine itself. A vaccine failure is when an organism contracts a disease in spite of being vaccinated against it. Primary vaccine failure occurs when an organism's immune system does not produce antibodies when it is first vaccinated. Vaccines can fail when several series are given and fail to produce an immune response. The term vaccine failure does not necessarily imply that the vaccine is defective. Most vaccine failures are simply from individual variation in immune response. So with this, I want to mention that many people are a little scared about vaccinating because they are not really sure about their effects. So as a personal experience, I could say that I already took my vaccine. I didn't have any side effects. I didn't feel any symptoms that I could say, oh, is my health in danger, or I am not gonna do it again. No, to tell you the truth, I didn't feel anything. Didn't feel anything, and I had to go back again in 20 days in order to get the second doses. But I think I am contributing to pues stop the disease in my side and try to don't transmit this disease to anybody else. Even though, as we are going to see in a second video about how was the COVID-19 vaccine was developed and how effective it is because it is another variation of antigens. So I am trying is to let you know that it's very important. It's very important that we get vaccinated in order that we recover our economy, that we recover our jobs, that we really go back to our normality. So let's check this video that is going to tell us about a little more about COVID-19 and the vaccines that are already being uh, injected to people in order to they get vaccinated and improve their immunologic system. Where is it? Let me see. Mhm.
In December 2020, the FDA authorized two coronavirus vaccines, both with unexpectedly high efficacy. Let's look at what we know about these vaccines and what we have yet to find out. The first vaccine to be authorized was developed by Pfizer and BioNTech, and the Moderna vaccine was authorized a week later. Both are messenger RNA or mRNA vaccines. They work by inducing an immune response to the viral spike proteins. These are the proteins that stud the surface of the SARS-CoV-2 virus and make it look crown-like, which incidentally is where the coronavirus gets its name. You can think of the vaccines as target practice for your immune system, the target being the spike. But instead of the actual spike proteins, these vaccines contain the genetic information in the form of mRNA that codes for the spike. When the vaccine mRNA enters the cells in your body, it gets taken up by the machinery of those cells, which then make the spike proteins.
So we're basically just using the machinery of the cells to produce spike protein and put it in the surface of the cell so the immune system can then come and see the spike protein and then generate an immune response.
This immune response to the spike would help you fight a future infection with the SARS-CoV-2 virus. Importantly, the vaccine mRNA does not enter the cell nucleus, which contains the cell's DNA. So the vaccine has no effect on DNA or body genetics. The vaccine mRNA also does not replicate and it does not stick around permanently.
The mRNA disappears, it goes away, so it doesn't even stay in the cytoplasm of the cells. This is what the cells normally do. mRNA in our cells disappears after it forms protein.
Data suggests the highest levels of spike protein are produced 48 hours after vaccination and are cleared by 72 hours. The mRNA is actually gone even sooner, by 24 hours. Now let's look at the data on efficacy. The overall efficacy for these vaccines was determined by comparing the number of people who developed symptomatic COVID-19 in the vaccine and placebo groups in large phase 3 trials. Here are the numbers for Pfizer and for Moderna. So how do you calculate efficacy? Let's look at Pfizer. First, you divide the cumulative incidence of disease in the vaccine group by the cumulative incidence in the placebo group. This gets you the risk ratio. Then you subtract the risk ratio from 1, and the number you come up with is the efficacy. So the efficacy for Pfizer is 0.95, or 95%. Here again are the numbers for Moderna. Using the same calculation gets you an efficacy of 94%. These numbers are encouraging, but it's important to keep in mind that participants in both the Pfizer and Moderna trials were tested only if they developed symptoms of COVID-19. So while these data tell us if these vaccines prevent clinically recognizable disease, they do not tell us if the vaccines also prevent infection and transmission of the virus, which means a few possible scenarios could be at work for those who are vaccinated.
So, a typical scenario could be that someone is protected against infection, and certainly if against infection, against clinically recognizable disease. But there's also a likely scenario where someone is protected against clinically recognizable disease, but they still have replication-competent virus in their nasopharynx. Hence, by definition, they are infected.
And if that second scenario is at play with these vaccines, that is, that people who are vaccinated don't develop symptoms but still get infected, a follow-up question is whether these vaccines might still prevent or at least decrease transmission. According to Dr. Fauci, it is conceivable that the immune response that protects someone from symptomatic COVID-19 would also lower the amount of virus in the nasopharynx.
So you could be infected, but not have enough virus in your nasopharynx to transmit it.
Studies are already underway to figure out whether these vaccines prevent infection and transmission as well as symptomatic COVID-19. Some very preliminary data indicate that they do, and more data are expected soon. But given the uncertainty, public health authorities are recommending continued preventive measures like mask wearing and physical distancing, even for people who have been vaccinated. And there are other unknowns when it comes to efficacy that are still being researched, like the duration of immunity, whether the new virus strains could make the vaccines less effective, or how efficacy varies for different demographic groups. Now let's look at safety. The FDA would normally want to see at least 2 years of safety follow-up data for a vaccine. But given the urgency of making an effective vaccine available for pandemic control, when these vaccines were authorized for emergency use, only about 6 months of follow-up data were available for the earliest and 2 months for the phase 3 trial participants. According to that data, the most common reactions were pain at the injection site, fatigue, and headache, most often after the second dose. Most adverse events were mild to moderate and resolved within a few days. Such reactions are to be expected with all vaccines and are most often just a sign of the immune system working. Importantly, even though these vaccines have already been authorized, safety monitoring is ongoing.
Safety considerations go well beyond the clinical trial. There's observation of potential adverse events, well into the implementation of the vaccine distribution. So if you look at the numbers of people in the clinical trial, there were 44,000 in the Pfizer trial. Once you push the button and start distributing vaccines, you're going to be giving it to millions of people.
And you're only going to find out a rare serious adverse event post approval. That's definitely true. That's always true. But the good news is there's systems in place like the vaccine safety data link or VAERS or the CISA system to pick that up.
These are government systems designed to detect post-approval safety signals, and the US has ramped up its safety surveillance capabilities for COVID-19 vaccines. An example of these systems at work is the recent publication by the CDC of data on severe allergic reactions, also called anaphylactic reactions. The US got a heads up about anaphylactic reactions after 2 cases were reported in the UK on December 9th. A CDC analysis published in JAMA reports on more than 9 million administered doses of the Pfizer vaccine and more than 7 million doses of the Moderna vaccine. The rate of anaphylactic reactions was 4.7 cases per million doses for the Pfizer vaccine and 2.5 cases per million doses for the Moderna vaccine. This is slightly higher than the rate of anaphylactic reactions following flu vaccination, for example, but still extremely rare. 2 months into the vaccine rollout, both the Pfizer and Moderna vaccines still appear to be safe.
It's amazing. I mean, here you have a virus that this elusive, difficult to characterize virus that's had a number of clinical surprises and pathological surprises who are meeting with a technology, messenger RNA vaccines, with which we have no commercial experience. I mean, I think anybody who was paying attention to this was worried that there might have been something unpleasant that we were going to find out eventually which we knew now. But for right now, no. I mean, Maurice Hilleman, who I consider the father of modern vaccines, said it best. Quote, I never breathe a sigh of relief until the first 3 million doses are out there. Well, the first 3 million doses are out there. First 40 million doses are out there in the U.S. and hundreds of millions of doses are out there in the world.
FDA and CDC scientists and others are continuing to watch safety and efficacy signals vigilantly as more and more people get their doses. Continuing research should help us answer key remaining questions. And some of the uncertainty is the byproduct of getting two remarkably effective vaccines to the public within just 11 months of the virus being sequenced.
I think it's reasonable to be vaccine hesitant. I think, it's a frightening virus. A lot of the language that surrounded the development was a little scary. Operation Warp Speed, race for a vaccine, who's going to be the first across the finish line? That's a little scary. And it's a novel technology. I mean, I think you reasonably could say, wait, let me just see how this plays out initially. Well, it has played out. I mean, once 40 million people have been vaccinated, I think you now have a large platform on which to stand that you can say the effectiveness is remarkable. And the safety, as far as we know, appears to be reassuring. I think we're all vaccine skeptics. I think everybody who sits around the FDA Vaccine Advisory Committee table is a vaccine skeptic. You want to see the data. Well, now you have the data.
Okay.
Researchers are racing towards the goal
Sorry.
of delivering a safe and effective vaccine that could curb the COVID-19 pandemic.
I'm sorry. Okay. The purpose of this program today was to let you know a little bit more about the COVID-19 vaccine, right? It has been proved in more than 40 million people in the United States, and it is being monitored about the side effects. It is important to know that we have a 90% of effectiveness in this vaccine, and it is time to protect ourselves, to protect from getting this disease, protecting our family, protecting the society. And even though, as you could see in the video, if you get infected once you are vaccinated, the virus that you have, even though you are infected, the virus that you have is not strong enough to contaminate or to infect other people. So the effectiveness of this or the efficacy of this vaccine has been proved to help get a protection from this disease, and it's time to we take some responsibility in protect our family and our society. So that was basically the program today, trying to inform people that a vaccine is not a way that you are getting infected. No, it's a way that you are going to get protected against this pandemic. That is one more, as we show you in the first video, that this is not the first pandemic that we have in our lives. There were 100 years ago was another pandemic. 3 centuries ago started the pandemic of the smallpox, and then probably in the future we are going to have another different pandemic. But in this case, we now at this moment we have the light at the end of the tunnel for to fight this pandemic. And personally, I invite you to vaccinate. I mean, my personal experience was good. I don't have any regrets about being vaccinated, and I just expecting for my second doses, and I feel a little more. I don't know how can I put it. A little more protected could be the way. Well, anyway, stop thinking that this vaccine is going to harm you instead of protect you, and I invite you to get the vaccine. Ok, en estos últimos minutos que nos quedan del programa, quiero invitar a toda la comunidad universitaria a que informarles de que las inscripciones para los próximos niveles de inglés ya están aperturadas. Ellas ya empezaron desde el día de hoy hasta el 11 de junio, en la que ya está abierta la plataforma para las inscripciones de los diferentes niveles de inglés que desean realizar. Recuerden que el 11 de junio se cierran las inscripciones para los cursos que van a empezar a partir del 12 de julio hasta finales de agosto. Es el periodo en el cual van los próximos cursos, julio-agosto. Y en su momento, pues estaremos informándoles sobre las subsecuentes inscripciones para los otros niveles que irían en septiembre-octubre y eventualmente en noviembre-diciembre. Pero es para que informarles nuevamente que las inscripciones se aperturaron a partir del día de hoy y que se van a cerrar hasta el 11 de junio, ya que en ocasiones anteriores, pues no sé, la gente dice que no se dio cuenta, que no sabían de que se habían abierto las inscripciones y que no se pudieron inscribir al curso. Básicamente, en algunas ocasiones ya estamos a mitad del curso y están pidiendo de que por favor se reaperturen inscripciones para entrar a esos cursos que ya pues van un poco adelantados, y es como de antemano proveerlos con esta información para que no se dejen coger el tiempo y no se queden por fuera de las inscripciones. Entonces, esa es como la información que quería darles a la comunidad universitaria para que lo tengan presente y no dejen pasar la fecha de inscripciones. Okay, ladies and gentlemen, this was it for today. Thank you very much for your audience, and I hope to see you in the next week with a different program. Thank you very much. Bye-bye. See you.
Ladies and gentlemen, welcome.
Where you live the language.
Classroom C2 for business.
Classroom C2 for life and culture.
Classroom C2 for education.
Hello. Hi. Good morning. Good afternoon. Good evening.
Classroom C2 at the cutting edge of technology.
Classroom C2,
Where you live the language.